Hey guys, welcome back. Arun Sharma Academy पे with me Arun Sharma on the Arun Sharma Academy, and this is another lesson on triangles, which we are looking at, trying to simplify geometry for you, the understanding of geometry for you, and of course, as I've told you, the first aspect of simplifying geometry is to get all the formulas in place, understand all the formulas, in-depth understanding of all the formulas, getting all the formulas in place. And in that context, the first couple of lessons that I've done were on triangles. Or triangles mein class 6th or 7th mein, what we studied about triangles is what we have discussed. And when I looked at the NCERT books, class 8 actually gives a bypass to triangles. There's no triangles chapter in class 8. So the next time they pick up triangles in NCERT books is class 9. And these videos are supposed to help anybody who's trying to improve his geometry, whether you're a school student studying for this particular class, or you are a competitive aspirant or later in life student who's trying to improve the quality of his geometry. So the organization of this course is built around individual classes and the chapters that you would see in NCERT. So I'm taking you through today in this session. I'm taking you through class 9th NCERT triangles. We are going to look at what are the key theorems. That's the agenda. The discussion of the theorems of class 9 triangles is the agenda here. Getting those theorems clear and getting those theorems in place. And if you're liking what we are doing, if you are enjoying what we are doing, please do share the links of the videos. So coming to the topic at hand, we have already seen this in class 7 geometry, triangles, the 4 rules of congruence of triangles, where we had seen that if you know the 3 sides or if you can prove the equality of the sides of one triangle with the other, you get two congruent triangles. It was called the side rule of congruence. Then you had the side rule and the angle rule. That means if you know 2 angles and you know the included side, and you know 2 sides and the included angles, then you also can uh, conclude congruence of the triangles. And the 4th rule was the right angle hypotenuse side rule. That means if there are 2 right angle triangles in which the right angle is equal, of course, the hypotenuse is equal and one of the sides is equal, then automatically the two angles or the 2 triangles end up becoming congruent. So this is something which you have studied in class 7. The class 9th NCERT books also starts with a discussion of these rules of congruence. And once these rules of congruence is done, then they introduce another rule of congruence, which they call as the angle side rule of congruence. Now, what this rule of congruence is, it's different from the ASA rule, and it says that if you know 2 angles of a triangle and a side that is not included, then you can draw only one triangle through that. And hence, if in 2 triangles you know 2 angles are equal and a side that is not included is also equal between the 2 triangles, then the 2 triangles would be congruent to each other. So let's have a brief look at this rule. What does it entail, and what does it tell us? So let's have a brief rule of this rule. Let's do a little bit of freehand drawing here, or blackboard drawing here. So what it's saying is that if I know a side, and essentially you need to understand that if I know 2 angles of a triangle, then there's what can be called as the included side between those 2 angles. This is the included side, and the other 2 sides are the non-included side. So when you talk about a situation where you're talking about a side or 2 angles and the non-included side, it means that let's say this is the side AB, which is non-included between the angles B given to you. Let's say the angle B is given to you as 30 degrees. And let's say, so if the angle B is given to you as 30 degrees, what happens is that you can actually predict that the third point of the triangles, the point C on the triangle, will lie somewhere on this line. It can lie anywhere. If you're just given that the side AB has some length, and it's not a very straight line that I've drawn, but you can understand what we are saying here, that the point C will actually lie anywhere on this line. AB is defined, let's say this is defined as 5 centimeters for you, and angle B is defined as 30. So C can be anywhere on this locus of points, which can take C anywhere on it. It can be here, it can be here, it can be here. But the moment you define an angle at C, let's say if you say that the angle at C is 60 degrees. So the moment you define an angle at C, then the point C gets defined very clearly, because if you draw C from here and that is 60 degrees, if you draw C from any other point, the angle will change. The angle to A would keep changing and will not give you that 60-degree angle. So this is why this is called the two angles and the non-included side congruence of triangles. And अगर थोड़ा सा reflect करो तो you also realize one more thing, कि ऐसा कोई इसमें बड़ी बात नहीं है, because if you know two angles, you also know the third angle. We know that the three angles of a triangle measure 180 degrees. So if you know two angles, one is 30 and the second is 60, the third angle as 90 automatically gets defined. If you know one angle as 50 and the other angle as 70, the third angle automatically gets defined. So जैसे ही third angle define हो गया, because you know the first two angles, so what happens is that it actually becomes the ASA rule only. So there's no big deal about this rule, although they give you as a new theorem. You don't need to take too much bother, too much worry on this. ऐसा नहीं होगा कि तुमको ASA दिख गया, AS दिख गया, you have seen AS and you've not been able to see ASA. So that's why you don't need to bother too much about this rule per se. लेकिन ठीक है, it's when you're covering your class 9 geometry, you should know what they tell you in the books. So this is what I have depicted here, that if you have a line AB whose length is known, and you know, let's say one of these angles at B, you don't know the other angle at A, and the moment you are told, so if you know that angle B, then the point C can be anywhere, C dash, C double dash. But if you are told an angle at C as the second angle, and then the non-included side AB is given to you, then C's position gets fixed at C specifically in this figure, and C dash and C double dash cannot be where C lies. And the moment that happens, the triangle pretty much gets defined. The whole triangle gets defined. You cannot change anything about this triangle after that. So that's why this is the rule of congruence that comes up. And as I said, there's nothing but the ASA rule actually. If you just think one step ahead, that if you know two angles, you know the third angle. Okay, now there are a couple of more rules which are slightly more important than this, that you learn in class 9th. The next theorem is that angles opposite equal sides of an isosceles triangle are equal. Now you know that an isosceles triangle is a triangle that has two sides equal. So the opposite angles to those equal sides automatically become equal. And this is an important rule, very obvious rule of course, but a very important rule in class 9 geometry. And its converse is also true. The converse is, if two angles are equal in a triangle, then the sides opposite those angles would also be equal. The sides opposite equal angles in any triangle would be equal. And that means, of course, then if two angles in a triangle are equal and the sides opposite them are equal, then that triangle which has two equal angles and a third unequal angle will also be an isosceles triangle. So this is basically specifically a rule for isosceles triangles. And then there's a rule for scalene triangles, which talks about the inequalities of angles and sides. And this says that essentially it says this is the exact language used in the class 9th book. But you need to understand basically this, that if there is a triangle which has one larger side and a smaller side, then the angle opposite the larger side will be larger and the angle opposite the smaller side will be smaller. It's as simple as that. So if I look at this again, or if I try to show this to you again through a visual on a blackboard, let's just see what we mean to say here. So let's imagine you have a triangle whose side AB, let's say, is this length, and the side BC let's say, is this length. So what this rule says is that once AB and BC as lengths get defined, the third length automatically gets defined. And because AB is larger as a side than the side BC, the angle C, this angle which is opposite AB, will be larger. The angle C will be larger than the angle A, which is opposite the BC side. The angle C will be larger than the angle A, because AB is larger than BC, right? So this is the rule of inequality of angles and sides, and the converse is also true. The converse of this says, the converse of this is also true. Let me just show you what it says. So converse of this tells us that in any triangle, the side opposite the larger angle is greater. So if there's an angle with unequal if there's a triangle with unequal angles, the side opposite the largest angle will be the largest. The side opposite the second largest angle will be the second largest. The side opposite the third largest angle will be the third largest, or the smallest. So take an instance. Let's say there's a triangle with one angle 100. Let's say angle A 100. Then the side BC, which is opposite angle A, will be the largest side in that angle, in that triangle. Let's say the other angle in the triangle is 50 and 30. Let's say angle B is 50. And then the side opposite B in a triangle is side AC. So AC will be the second largest side, and if angle C is 30, so AB is the side opposite 30, which will be the smallest side. So these are two important rules with their converses. And then the third important rule or theorem that is taught to us in class 9th, which is actually very important, but it's so obvious that maybe they should not have told us this as a geometry theorem, but as a practical real life situation. And this is a very simple practical experience. The sum of two sides of a triangle is greater than the third side. Didn't you know this forever? I mean, simple thought. If you want to go from Delhi to Mumbai, should you take the straight route? Will that be shorter, or going through Kolkata will be shorter? If you have 2 points, A and B, 2 points on a line, the straight line distance between the points will always be the shortest, rather than going through a third point, which is outside that line. So if you're going from Delhi to Mumbai, there's a straight line connecting the two. If you go on the straight line, as the crow flies, as they say, even crows know this theorem, that the straight line is always the shortest path between 2 points. So this rule is actually just reiterating that point, that if you connect 2 points directly, that length will be shorter than the connection through a third point, right? So this is a rule that you should understand instinctively, and this is something you really can't forget, because you've known this from the time you were a 2-year-old child. So there's no need for this to additionally add to your tensions about what triangles are and what theorems there are in triangles. So chalo, I hope you like this video. Please do spread the word around. Please share, please like, please comment, please do share, spread the word around. It would be great if more people benefit from our work. Also give us a lot of enthusiasm to do more work for all of you, and bring out more knowledge sharing and simplifying videos. And as usual on the Arun Sharma Academy, the whole idea is to make learning fun, accessible and simple for all of you, and enjoyable for all of you. So I hope we are going ahead with that journey, and I hope you are enjoying that journey along with me as much as I enjoy bringing these to you. Right? Thank you so much. I'll be back with another video very soon. Bye-bye.